facility team, highlighting those working with the team, and then in certain facilities where there were issues which couldn't be understood by just implementing the changes, there's been pilot projects that are being contemplated right now to understand those operational changes. And then finally, the scope of work also included documenting energy and emission savings in these facilities to understand what is the results that come out of this, and we'll show those as examples as well.
Sorry to interrupt again. Actually, I'm not, but this is the ongoing process coming out of here, right? We will be tracking the energy use in hospitals where they're implementing these improvements. Yeah, I'd love to come back a year from now and say, wow, it really happened. Look at these numbers. Holy cow.
So most of these hospitals we're talking about, they're part of the Green Healthcare members anyway. So there's a couple of hospitals which participated as a part of non-members. We'll be working directly with those hospitals to make sure that that tracking process is there, and we establish that, and then the results could be shared with other hospitals. Because there's one of the things that came out of this is there are unique circumstances in hospitals. So and then there are also similar circumstances, which is going to good segue to the next slide. But there's a lot of learning to happen among the hospitals. So which is the key for this project. Was one of the success was to share those learning experiences among hospitals.
Deep, I've started the recording for this this meeting.
Yeah.
Just so people know, feel free to contribute still. We are recording it, but it's not going to be posted anywhere. It's just Harry was looking for to use this with AHS after.
Awesome.
Okay.
Okay, here's the summary or the key findings in majority of the hospitals. So is there, so I'll go in detail in each of them in more detail, just summarizing what are those items are, where they've been found out. But like when you look at the list of the hospitals, the single most predominating factor in all of these and in a majority of them is the preheat set point too high in all of the facilities. So that's one of the most single factor that's contributing to inefficiencies or underperforming of the thermal wheels, where other factors are also important, but this is the most important factor, and it's most simplest factor that's contributing to underutilization of the thermal wheels in the facilities across Ontario, BC, and Alberta, and it's a consistent theme across most of the facilities. There are other, like as you see, there are more factors involved in different facilities, and some of them are unique to each facility. Some of them are common among different facilities. But preheat set point, thermal wheel underperforming, and sequence of operations, those are the key sort of factors that are influencing the performance of the wheels. And then positive pressurization causing wheel leakage, which is more predominant in AHS sites, and I'll sort of present a slide on that as well. And then there's snow built up. Again, it's sort of a unique to a couple of hospitals where there's an issue with, or one hospital where there's an issue with that, which is limiting the factors as well. The steam preheat is also a limiting factor on the hospital. I'll touch base on these in a second in the rest of the slides. As I said, the preheat set point too high. This is generally what we found in majority of the sites is, and there are different reasons each of the sites why the preheat coil are set or the preheat coil temperature set up too high, and sometimes the facilities are being handed to the facility or facility teams by the construction divisions with this setup. Sometimes the consultants have given them or given set points to the controls contractor, which has never been verified or never been sort of tested to the design limitations. And there's many other factors which eventually have resulted that the preheat set point on all of these coils have been set too high. What happens with that is that the temperature that entering air temperature on the wheel then it results in diminishing the capacity and the actual operations of the wheel as the preset point is set high. And generally they are set above 0 degree C. And one of the reasons, or one of the considerations we heard, is that it's done to prevent the frost protection on these wheels. However, when you look at the psychometric analysis and look at the shop drawings of these wheels, the frost protection doesn't kick in most of the fields, even close to -15 degrees C. And in certain cases, they have even recommended going below -15 degrees C as well. There are many facilities which are currently running the preheat coil temperatures below -15 or close to -15 degrees C, which includes hospitals in Alberta and Ontario. So it is a sort of a safe operations to do in majority of the climate weather. However, like the recommendation that you see in certain facilities, because they're older, they have a different infrastructure. So we're recommending sort of using approach where you're incrementally reducing the supply preheat set points lower, so you can sort of look at the limiting factor in your existing systems. The second most common factor that we've seen is the thermal wheel underperforming. If you look at the graph on your right-hand side of your screen, this is a graph of the thermal wheel entering air temperature versus the outside air temperature. So, or versus the delta T. So, if you look at from right to left, as your entering wheel temperature increases or decreases. So if you follow the extreme example here, like -15 degrees C, your expected delta T per the design is around 26.5 degrees C. So you should see a supply air of around 11 degrees C coming out of the wheel if your entering air temperature on your wheel is -15. However, if your entering air to the wheel decreases, as you see as you come down the slope, your delta T across the wheel also decreases, which is basically limiting your capacity on your thermal wheel. So in this example, or particular example, the delta T at delta T at 2 degrees C was expected to be around 15.50, where the wheel was only delivering 9.66 degrees C. So from this analysis, you could suggest that, okay, the wheel definitely is not performing to the design condition, because at the design condition, if the entering air to the wheel is 2 degrees C, then your delta T coming out of the wheel should be 15 degrees C. However, the delta T, what we're seeing through the trend analysis, were 9.65. So this kind of points to the next step. There is definitely an operational issue, or the wheels are underperforming. So in this case, in this hospital, what we recommended is to, because we didn't have the air testing reports to confirm whether there's an issue with imbalance in the airflow, or whether there's an issue with the wheel not working, or whether there's an issue with actually wheel needs cleaning, its performance had deteriorated over a year, or whether that's an issue with the media. So all of those issues could sort of let your wheel underperform. So the next step in that case is to just look at what is starting with air testing and then confirming that the regular maintenance of the wheel is done and the media is good, so that you get the design values.
So Amandeep, did you do this testing on all 10 hospitals to part in this?
Yes, so this analysis on underperforming of the wheel was done on our hospitals, and some hospitals we can do it because the trends were not available, but majority of the hospital where we had the trend, we did that analysis.
And did any of them come out close to design values? Were they running pretty? Were any running close to where they should be?
Yes, most of them came close to design values. So if you go back to this, in majority of the cases where we don't have these marks, so in those hospitals, they were close to the design values.
Okay, and we're speculating at this point on what gets in the way, or whether it's air imbalances between supply and exhaust, because air testing hadn't been done. Did any of them have air test reports on either side of the wheel?
No, if they were probably old reports. Some of the facilities had airflow monitoring stations, so we use those to
Okay,
determine, but most of the facilities didn't have a testing reports. Either they were there, but they're too old to rely on.
okay, thank you. That's helpful.
The next anomaly that we noticed on certain hospitals is around sequence of operations, and there's many sort of sequence of operation anomalies, but this is sort of a general description of the anomalies that you would see, which would limit again your heating wheel performance, or it will limit when you could run the wheel. So in this example, what you're seeing here is that the wheel at minus 10 degree outside air temperature was running at 20%, which is what's more than enough for this unit. It seems like the wheel was oversized, but it was delivering the right amount of supplier temperatures that's needed for that facility. However, if you take it forward to a couple of weeks, the wheel on a couple of occasions went to 100% for no reason, even though, well, obviously there's a reason in the programming code which led this to run to 100%. But if you look at it, what's needed from the wheel at minus 10 degrees C, you only need 20% of the wheel running to satisfy your supplier temperatures, whereas when it's around 2 degrees C outside or 3 degrees C outside, the wheel went to 100%. So it's kind of counterintuitive that you only need 20% wheel at minus 10, what you need 100% wheel at 10 degrees C, or 3 degrees C. So this is generally pointing to the BAS programming anomaly, where one part of the sequence is calling the wheel to suddenly come on to satisfy for certain reasons. So this is something need to be digged deeper into the programming code to understand why the wheel's coming on. It not only sort of it doesn't impact the sort of the gas consumption directly, but it does impact the operation of the wheel, which sometimes limits how the wheel could be operated. Because during the shoulder period, this phenomena happens more often for this facility. So which was giving them a lot of trouble in running the wheel at the shoulder season, which again limits the operation of the overall operation of the wheel.
Sorry, Amity, what's the problem caused when it goes to a higher speed? It uses more power on the wheel, but that's not a big deal. Other operational issues that arise?
Operational issues. There's operational issues because now you can't control the supply temperatures to deliver at the consistent. So it just fluctuates, and then the heating coil comes on or other factors comes in, which again makes life difficult for operations team.
Thank you.
This is possibly pressurized thermal wheel causing leakage. So this is primarily the issue that we've seen in a lot of AHS facilities. And I think Carrie and I had a conversation about that. It is something driven by the design of these units. So if you look at most of the Ontario hospitals, the supply fan is downstream of the wheel. So it's kind of, the wheel is negatively pressurized in those cases, whereas a lot of, I would say pretty much most of the configuration we've seen on the AHS side is the fans are upstream of the wheel. So what happens is that now the wheel is almost at a 7 to 8 inches static that it's sort of seeing, because that's what the fans are producing to overcome the heating coil, cooling coil, filters, and everything else. So there's a huge pressurization that happens, and which eventually results into the leakage, which is not a bad leakage in a sense that it's a leakage from the supply and exhaust. But what it does is it prevents the wheel, but it sort of, the units are underperforming because of that leakage, and what results in certain cases is that the units, in order to satisfy the airflow at the discharge, they have to run the unit at a harder speed or harder than what's originally designed for. And in one hospital, because of that, there's a lot of snow being pulled because now the wheels or the unit is actually running at a higher velocity. And the dampers are not sized, or the louvers are not sized for the higher velocity, which generates that entrainment of the snow, which again builds up on these cooling coil or heating coils, and which hinders the performance of the wheel indirectly, because now you have to run the preheat coil at a higher temperature to melt that snow and other issues. But I mean, that's one issue is I see the point that it's kind of been done to avoid cross contamination, but a similar configuration or an opposite configuration where the wheels or the fans are downstream of the wheels being used in target hospitals with no particular issues about cross contamination.
And Amandeep, could you just speak briefly on when we got the fan downstream of the wheel, what's best practice around maintaining that negative pressure so it's still going in the right direction, it's still positive relative to the exhaust side? Are there controls in there that help with that?
So the units are generally sized to have a purge, which is purge from the supply to the exhaust. So that ensures that you have a discharge from the supply to the exhaust side. Your flow of the air is from the supply to the exhaust side, and also when they're balanced to make sure that purge exists in these units. So I mean, obviously with operations, things could change, and that's why we always recommend to test these systems to make sure that there is no cross contamination. Another thing is to ensure that your seals are properly, well, your seals are sealed properly closed in this case, so you don't expect those cross contamination or but the key to this is to make sure your balance of the supply and exhaust flow is maintained, and your seals are properly aligned so you don't get that cross contamination with these systems.
And how would the hospital know that as you say, that the purge is going in the right direction, that it's going from supply to exhaust? How would you know that? Is there an indicator?
There's no indicator. I think that will be confirmed through their testing. It could be confirmed through smoke test to see the flow of the movement of the purge. But that's generally done through their testing performed by the tap contractor to confirm that it's in the right direction and there's no cross contamination happening.
Because that's what the impression I got from you last night is that we need to be testing these supply and exhaust fans and making sure that everything's going in the right direction. And the majority, if I understood correctly, the majority of hospitals aren't doing that basic TAD testing of these units.
Yes, that's not in generally the scope of work, and it could be an easy add to the existing contracts because there's PM work on these units done regularly, but it's just a matter of adding that scope of work to those, so it's included as a part of the regular PM.
And this should be done now, like for these. If we don't have the testing now, this should be an immediate thing for hospitals to do. Is that correct?
Yes, especially where we do see the performance issues. So that's the first step in those ones.
Yep.
And we can say for the other ones, you can sort of bring that in your regular PM cycle, but immediately for the ones where we're seeing performance issues, it's actually linear. Okay, this is again, it's a unique scenario at one of the hospitals. It may or may not apply, but again, we are seeing a lot of these unique scenarios, and they when you sort of put this across facilities in whole of the Canada, North America, they become more common issues in a lot of the facilities. So this facility, what's unique in this air handling system is that they don't have a heating coil. So they have a preheat coil, but they don't have a heating coil. They use the cooling coil in the wintertime to extract some of their load from the 24/7 systems to provide some additional heat rejection through this coil, but it's not enough in cases when it's cold outside, and I'll explain that in a second. So if we in this this is one of the hospitals where they actually implemented the changes were recommended. So they started with -10 as a preheat and -15. So what's happening was at -15, you would expect if you're entering air at -15, you would expect the delta T across the wheel 12.6, which would take you to, at a design level, will take you to around 11.5 degrees C. However, we're seeing around 10 degree or around 8 degrees C on that system. So there is potential little bit of underperforming on the wheel side that could be improved if it's been brought back to design. However, when you have a supply temperatures of 10 degrees C, their discharge requirement is around 13.1. Even with the cooling coil, they cannot maintain that 13.1 degrees C discharge their temperature. So in order to meet that, they had to do is to increase the preheat set point, because there is no other way for them to add heat to the system at this current configuration. So they had to increase the preheat set point, which, as you see from this graph, when you increase the preheat set point, which means your entering air temperature to the wheel is going to increase. So which means your delta T is going to decrease across the wheel. So you're indirectly underusing the wheel by reducing or increasing a preheat set point. However, this is sort of a unique scenario again in this facility, because they did not have a heating coil downstream. They could not maintain the supply temperature, so they had to increase the preheat set point higher to achieve that discharge air set point.
So Amadou, sorry to keep interrupting, but this is, you're just using this control diagram to explain the problem that with the absence of a reheat coil, if you haven't got the supplier temperature you're looking for, then you have to pump it in preheat, and that kills the wheel.
Exactly.
That's not what's happening here, right? Because it's 13.1 degrees Celsius outside.
No, this is just a one. The background is used to explain the
right. So this is just illustrating the system.
Exactly.
Yeah, that's not what's happening. Yeah. Okay.
No, that's not what's happening.
Got
at
it.
that
Thank
point
you.
of time. Okay, so other issues. This is an interesting one, and I think it's happening at a couple of the HS site, is around the snow built up in the intake plenum or preheat. And as I was explaining, this is, we believe, primarily because the units are running at a higher velocity across the outside air louver and through all of the components, which is dragging the snow intake or snow into the outside air intakes, and also all the way towards the first preheat coil. So which again, it's a combination of few things. One is AHUs running at a peak capacity. The second is the design for the outside air louvers and the ductwork, which is, again, all of this is limiting, is not only giving trouble to the facility operations team, because they're trying their best to run these systems, but they're stuck with this issue where their systems are sort of performing at an undersize in terms of the amount of air that's need to be delivered. So they have to run those systems at a higher speed and higher airflow. And then also the outside air louver and the ductwork design isn't aligned to make sure that you don't get that snow built up in those coils. So there's one of the sites where we're currently doing a pilot now to see how we could mitigate this effect of snow build for majority of the heating season. There's going to be days when the snow will start to accumulate, but what other things we could do to make sure this snow accumulation doesn't happen, or we can sort of use the technology with reading the weather and sort of bumping up that preheat temperatures if it needed for that particular days, and still use the lower preheat set point for the rest of the period, because that's where we're going to get most of the savings. So that's a pilot that's been tested in. It's going to be tested in October this year.
Yeah, I mean, this is a big deal, right? This was the big issue at Alberta Children's, wasn't it? That
yes,
that we had snow build up. We just had to keep the preheats running, and that again that kills the wheel. Between the different hospitals and air handling units you looked at, where because presumably a number of air handling units don't experience that issue.
yes.
Were you able to document the differences between them? Was it longer spaces between the intake louver and the coil? Was it the velocity of the air coming through? Like, were you able to see, we don't have a problem with these units, but we do have a problem with these, as kind of a design instructional, if that makes any sense?
No, that makes sense, and I mean that's the part of the next step in is to, because first we analyzed what's the actual problem is. So next points, I mean, exactly to your point, is to understand what is it a fundamental, to me, there's two fundamental things. One is the design, and the second is the operation of the units at higher velocity. So, which is sort of helping that cause of bringing the snow. If we slow down these systems to normal operations of air velocity, we might mitigate half of that issue by just not bringing that to, because another thing is some of these sites have predominant wind blowing in there. So that's a consideration probably should be considered at the design. If your site has high wind tails, then you should consider putting in additional factors in the design. I don't know what that is, but it could be additional space for your outside air plenum, so you get enough space for snow accumulation in the plenum, and then you have your systems next to it. So that, as to your point, maybe an extended ductwork that would sort of make sure that you don't keep pulling this air, keep pulling the air with the snow into your system, which is sitting next to your outside air plenum.
That's one of the reasons I like these cohort projects, is because when you're looking at multiple units in multiple hospitals, if we got a problem in some and not a problem in others, you can compare and contrast and figure out that's the difference, and then we can publish that, right, as this is a good design practice or a good operation practice. So thanks, this is helpful.
Yeah. The next one, again, this is one of the unique, or not, I wouldn't say supplier temperature control, which is again it sort of goes back to where the sensors are located, and especially this is the sensors which are located close to the wheels leaving temperature, because these are huge units. The wheels are big. It takes time for the air to mix, and if you have a sensors downstream of the wheel which is reading, it could read different temperatures anywhere from 0 to 10 degrees C all the way. And then when that sensor reads that temperature, because it's connected to a PID loop next to sort of heat up your or to sort of bring on the heating coil to reach the supplier temperatures, the issue that we're noticing is that there is sometimes incorrect feedback from these sensors, which triggers the heating coil to come on, and then it overheats the supplier temperature, which then backs up the heating wheel to say don't do heating, and then this whole process eventually results in inefficiency of the heating wheel. It is a control issue, but it's an issue related to where the sensors are placed, what are they being used for, how are they calibrated, and are you using sort of an average value across the sensors to bring on your heating coil. So this is an issue where it's a big systems and the sensors are not accurately or placed to where they should be. So again, a lot of lessons learned from that is the placement of the sensors, how they're being used, what type of sensors should be used in the facility. So that this could probably apply to many of the facilities across different provinces. Stream preheat coils, again, this is older systems, and it's again unique to one of the hospitals, may still be applicable to other hospitals which are still running steam in the preheat coils. So the preheat coils, as per the manufacturer recommendations, are for this particular hospitals, they are running at a certain pressure to maintain the avoid the freezing in those coils. However, there's another factor which is operating the steam valve is the preheat set point. So there's two. So if you think of this as a sort of two-step function in controlling your entering air temperature to the wheel, the first is to make sure that your steam coil pressure is minimum is there to avoid freezing, and the second is your preheat set point, which is set to a value which was higher, because that's limiting the performance of the wheel. As soon as we increase the preheat set point, as you've seen in the previous curve, your delta T on the wheel decreases, which limits your performance of the wheel. So a couple of other key issues, air imbalance, which again, it needs to be documented through the air testing, where and we have seen that in the past where the supply and exhaust airflows do not match, especially the exhaust airflows are lower than the design or the supply, which sort of again limits your performance of the wheel, because now the wheel doesn't have energy to absorb from the exhaust, which otherwise would have been there if the systems were balanced or there were no leaks in the systems. Thermal wheel low speed operation, again, this is another issue which is directly related to the operations of these units during the shoulder period, and also control of the supplier temperature, because these are huge wheels, and if they're not, if the motors and the VFDs are not sized to run to the lowest RPM possible, then during the shoulder season these wheels cannot be used, because they deliver either too warm air or too smaller, because they only could operate at a certain minimum RPM. So what happens in those scenarios is that the facility tends to not run these wheels during the shoulder season, which again limits the actual operations of the wheel for most of the seasons.
Is there a solution to that, Amandeep? Can you gear them down?
Yes. Yeah, so there is a solution. Yes, you could gear them down. South Lake at AHS have implemented that. Markham Stouffville have implemented that. I think they did. One of them did it based on the VFDs. One of them did based on the motors as well. So there is a solution out there, and it has to be worked out with the individual manufacturer of that equipment to make sure you get the lowest speed possible. And I think the best thing was to spec these correctly from the design point, from the starting point, is to make sure you get, because that's generally not done at the design stages, to make sure you get. This is not typical of other air handling units. This is very specific to the thermal wheels. So that design specification has to be adjusted to make sure you get these low RPM operations enabled on the wheels. So we talked about most of the recommendation. I just want to quickly touch on that. So resetting the preheat set points. Again, for older facilities, what we're recommending is to sort of incrementally do those, so you could test your systems and their boundaries. So you don't end up with a freeze-start tripping, because you don't want to do this sudden movement, but you definitely want to try the outer boundaries, how far you can push the existing systems, especially for older facilities. For the newer facilities, it's not whatever your manufacturer recommended set points is, it should be able to achieve that with no issues to any of the frost conditions or any other potential dangers of freezing the systems. Thermal wheel maintenance, as we talked about that as well. So regular checkup on that, making sure your air balances is there, making sure bearings and shafts are not damaged or misaligned, and your media is still recovering the heat that's needed for your system to put back into the system. The couple of pilot projects we talked about that are initiating to mitigate or understand the existing inefficiencies in the current design. How could you, where is again the boundary for your system to operate within those current design features? Because it's hard to change the existing design. It's a lot of capital, but there's still opportunity to use the technology to make the system work. Control sequence of operation review, that's absolutely for every system it should be reviewed, especially if you're getting an issues around maintaining a consistent supply of temperatures. It is driven probably through your programming that's not letting you get to your supply temperatures. And sometimes there's bypass dampers recommended. Generally, we see in the newer system, there are bypass dampers on the supply and the exhaust side. And what we are suggesting is that make them modulating, because you might need them one day. Currently, they're only 2 position. So make them modulating, so you have another variable to control your output for the wheel if you need it, if you're having issues with your supply temperatures. Just quickly, the savings potential, what we are generally seeing is between 5 to 13% across the facilities. The 5% which you see here is lower slightly because the calculations were done at a preset point of -5. It's because of the limitation of the existing infrastructure of the facility. But overall, there's a huge incentive in achieving those savings, and it sort of bring down your overall facility consumption by 5 to 13%, and our sort of rough number is around 10 to 13%, 10 to 15% that you will achieve if you have thermal wheels in your facility and if you optimize them to the recommendations of resetting those pre-set points. So again, it's also done through minor programming changes in most of the facilities. Doesn't need a lot of capital work to make those changes. Just want to point out these are Ontario hospitals, so there probably some or no incentives available at AHS. But again, like when you do this work, there's huge amount of incentive involved as well, which will offset a lot of your cost around testing these systems and making the smaller repairs on these systems. Okay, I'm going to open up the floor, and please, like, this is a conversation that we want to have with a lot of you to understand. You have seen or you have seen, like, we have previous conversation in the past, we've given sort of those measures recommendations to you, but this is more sort of how do we make those implementation, because one of the goals is, as even over the sort of for the green healthcare and sort of climate change network, to reduce emissions, and this alone is a significant factor in reducing emissions, and this is one of the easiest measure to do in the facility. So we want to understand from the folks out there, what at the ground level, what are you facing? Like, what are the, I mean, there's some challenges probably not listed here, but we want to hear from you. What are the key challenges that you're currently facing? And what exactly would you need to make these changes in your facility? So you can unmute anytime if you want to sort of share your thoughts. And again, this is an open conversation at this point.
There were a couple of questions in the chat too.
Sure, we can take those as well.
I asked about the VFD and a DC brake on it. Like, is that what you would need to be able to slow the wheels down? What I noticed is a lot of times the wheels will pick up speed due to the air volume going through them. We don't even have to engage the VFD to get the wheel to be spinning. That's
interesting observation. Sorry, Brent, could you introduce yourself if you don't mind, so everybody knows?
Yeah, I'm Brent. I'm at Grand Prairie Regional Hospital. I do temperature controls and HVAC here.
Thanks, Brent. So to answer your question, I think it is specific to each site in terms of what are the limitations for controlling those VFDs and if they do have issues. But I would have to get back to you on generally what we recommend is to sort of work with your VFD and the motor manufacturer, because they know the limitation on that equipment. And general principle that we have seen is that there's certain modification, whether to do with the gears or whether to do with the VFD itself, that would enable these changes so you could slow down the speed on these wheels. I hope I answer a little bit of your questions.
Are there other questions, Mike? Because I got one.
There was one more, Mike, right?
I think it also came from me. I was asking about I've been to quite a few hospitals in Alberta, and I'd seen several of them where the exhaust air is much less than the supply airs.
Yeah.
It seems to be, we've got a lot of isolation rooms, et cetera, that's exhausting directly to outside. So is this where you're seeing a large chunk of the inefficiencies on the wheel? Because you just can't keep up to, the design of that wheel with the lack of the exhaust air.
So generally what we noticed is the units were designed with a balance between the supply and exhaust. So in most cases, the systems were designed to have close to 1:1 ratio on the supply and exhaust. Which means that the air you're supplying, and especially these are 100% outside air system, in areas where there's no dedicated exhaust, so you would see most of the exhaust or most of the return from the systems come back to your system. But you're right, in case of isolation rooms, the exhaust has to be ventilated. But again, it depends on the design, but I wouldn't say this is a consistent across many facilities. I would probably say that it's more to see the supply and exhaust at the design are balanced. Yes, operational could be different, which is again needs to be verified why the exhaust the system is bringing lower. Because sometimes in certain facilities we saw is that whenever there's shell space renovated or retrofitted, tends to be more exhaust being put in those spaces as a dedicated exhaust versus general exhaust, which is again sometimes driven by the clinical folks, because they want to sort of have an absolute no contamination, which again in most cases wouldn't make sense, other than the isolation rooms and emergency department, and so there are certain other key areas. Everything else in the hospital could be used to recover the heat, because even though those other spaces which I mentioned could have their own sort of heat recovery, but definitely not a thermal wheel. But in most other spaces, you're allowed to recover the heat from the exhaust from that space.
So I mean, if you could wind up with an exhaust system redesign, because I noticed that Tanish from North York General's not. I don't think you're on the call today, Tanish. I didn't see you on the sign-up list, but in kind of casual conversation with him, the big reason to not do it was fear. It's never been done that way. Yes. And it's running just fine right now, and there's no upside for me to take risks here. And if the whole thing shuts down because of a freeze up, guess whose ass is on the line? So is it like confidence in people that like how can we document this well enough to say it's fine? And do we need kind of service contractors who are willing to go in there and say, look, I'll implement it, I'll take ownership of it? Like, how do we get past the fear factor? It's never been done that way, and it's been fine so far, and don't mess with me, even because they can't see the big savings, right?
Yeah, I think it starts with, I think there's combination of factors in terms of the science, or sort of you can say the thermodynamics of the system. We have reviewed that. We don't see any issues, and this is even the manufacturers. If you look at the shop drawings, this is what they're exactly recommending in terms of the preheat set point. So there's no concerns in terms of the actual operation or the actual design operations. I do understand the concerns because certain facilities are older, so you would have systems not operating as intended. Your sensors may not be working as intended. So there is potential risk of freeze trap tripping, for example, if you have air leakage through the bypass damper, or if you have air leakage through the wheel, which is not this, if it's not sealed properly. So again, the confidence and the fear has to be removed by support from the upper management as well, because this is the key, because they obviously they're doing it for everyone's cause. So that start from the top is to sort of give them a mandate. Yes, we understand there's a risk in here for older facilities. We understand that the system could trip, but we would only know if we tried, because otherwise we wouldn't know that how the system is performing. A part of that has to be before doing that, to ensure that you've tested the system, your leaks your seals are fine, your system, your sensors are calibrated, they're working fine, they're at the right location, and sometimes we've seen there's been overthinking in terms of sort of I wouldn't say bad practices, but the practices that have been followed in past. For example, there's been facilities which had cooling coils, they've been drained, there's been freeze stat in front of them, but still people were fearful to freeze the cooling coil. There's no, and in certain facilities they even had glycol filled up in the coil, but still they wouldn't try doing lowering those temperatures because there's still fear. It's been there for 30 years. Why would I mess with it, right? So that needs a confidence from not only from the facility teams, but also from the management to say, we support you, let's try it and let's do this.
So this is Patrick from Grand Prairie, the maintenance manager. For the people that don't know me on the call, where do we go from here, you guys? So we've talked about this. I think our friends from the COE are also on the call. So we're meeting with this team because we think this is a good idea. How do we get this off the ground? Where do we go from here? And the kind of I guess talking about the financial end of it, do we have an idea of what kind of costing would be associated with impeding this thing or impeding these ideas on at least some of our or all of our AHUs?
Yeah, I think I'll probably have Harry address some of your costing concerns as well, because I know they're supporting your project as well. But so Patrick, to answer your question, as I mean, in particular to your facility, the starting point is the pilot project, because again, this is one of your facilities where you're seeing issues with hoarse frost, and you're seeing issues with the snow built up in those coils. So as we talked about in the previous meeting, is to start small with the pilot project to test it on a couple of systems. And then understand where the design boundaries would let us work within that system, so we can implement those changes. And then from that, once what we learn from that pilot, it's going to be implemented across your facility. And we might be lucky in a sense that if we using the technology, using the upgrading, the programming and the controls, we might mitigate this issue completely with those few changes. It's just that we haven't tried that boundary in the past, but with this pilot, that's what we're going to try as to sort of test those boundaries about the designs and see how far we can go with implementing that change.
Okay.
And MD, the cost effectiveness of this is ridiculous, right?
It is.
Like getting the airflows tested, adjusted. Like it's less than $10,000 for an air handling unit, right? Probably less than 5, and the payback is crazy. So it's the risk, it's the fear factor that seems to be what gets in the way.
Absolutely. I think if you look at from just a simple terms, the payback on any of this is going to be less than 1 year. Even if I have to I don't even have to calculate that, because I can tell you most of this work's going to be done with a payback of less than 1 year. Yes, the biggest factor that we have experienced is the fear factor, and is that we've been running the facility and it's working. What's in us? Like, why would we do this, right? Why would we put an X on our foot? Like it's sort of that. And again, I understand a lot of these concerns are very genuine, and this is why we want to support through those projects whatever we could do to mitigate those fears and provide you technical supports and help you with that process, so we can collectively make those changes, because there's a lot of savings and emission reductions on the plate for us to not act on it.
Do you find many of the units are out of their design though? Like to take a slide off of a heat wheel, this is what the design should be, but the other portions of the system, like it is a system, not just a heat wheel, are out of that design. Like if our volumes are mix matched, that's an air balancing issue. We can't really overcome that system design flaw with a preheat coil temperature change.
No, absolutely. That if you have an operational or design issue, that this is how your system is balanced, there's other fundamental things that needs to happen before you could mitigate that or sort of engage your heat wheel to achieve the maximum efficiency or to reach the design levels. But in certain facilities, yes, there are design issues, but I think this is kind of given that in most of the facility you will find design issues. However, how do they impact the operations is different across the facilities. So to answer your question, I would say it's a sort of a mix and match. Certain facilities do have design issues, but they're minimal. They don't impact the heat wheel, but in certain facilities you have design issues which actually hinder your performance of the heat wheel. So it's unique to every facility. So I think, Michael, we're almost at the end of the time.
Yeah, I mean, we only had it going till 1, so we are actually a couple minutes over here.
So if anybody has any other questions, observation, comments, please feel free to reach to myself or Mike. You guys know our email. But this is for us as the next step is to sort of see the implementation in across all the facilities. And I'm open to one-on-one conversation so we can sort of help you take to the next stage and see those exact savings that have been confirmed in the previous observations. Thanks everyone for your time.
Yep.
Hopefully this was helpful and resourceful, and we'll connect with you soon.
Yeah, I look forward to it. I want to have a discussion with my team here to talk about what we need to do to try to have a couple units for the feasibility study, we'll call that. And yeah.
Awesome.
You're coming up next month.
Yes.
Look
Perfect.
forward to seeing you.
Yeah, actually this month. So I'll touch base with you.
Okay.
Yeah, that's great, Evan. I
Yeah.
look forward to that.
All right, take care, guys.
All right, bye.
Okay, bye.